In this video, we're going to talk about subtracting integers. And actually, subtracting integers uses the steps for adding integers. So this is a good point. If you're not comfortable yet with adding integers, I would stop the video, go back, rewatch that video, practice some more before you start subtracting integers. Because we're basically going to use the same or very similar rules in this section. And this is sort of the same idea. If you remember your fractions, when we divide fractions, we actually change to multiplication to make it easier. And we're going to do the same thing here. Instead of subtracting integers, we're actually going to change them to addition. But to do that, we have to make a complementary change to help kind of fix the problem. So I'm going to show you what we're going to do. So we do have a rule here, and it says that if A and B are numbers, then A minus B is the same thing as A plus negative B, okay? So subtraction is the same as adding the opposite. So what we're going to do here, instead of trying to learn all new rules for subtraction, we're actually going to use this rule right here and change it to addition. And the reason we can change to addition is we have to add the opposite. So when the middle sign changes to addition, then the second number changes sign as well. So we call this, or I kind of remember this as keep, change, change. So what that means is you keep the first number the same. You change from subtraction to addition, and then you change the sign of the second number. Okay, so we change it to its opposite sign. To its opposite sign. Right? And then what you can do, we're going to add using the addition rules that we've already learned. So we make a little change, and then we're able to, instead of having to create a whole new set of rules for subtraction, we can just use the addition rules that we already have. So let's look at a bunch of examples here to start. All right, so we're going to go ahead and just use this rule, So we're going to keep I'm going to do the first example. We're going to keep the first number the same. We're going to change from subtraction to addition. And then we're going to change the sign of the next number. So that positive 3 becomes a negative 3. And then what we can do is we can use our regular adding rules. So here, remember your adding rules. If I have different signs, I end up subtracting the numbers. And I take whatever there's more of. So there's more positive, so I leave it positive. Okay. So if you need your addition rules, you're going to have to go back and review them. But really quickly, if it's the same sign, we add and keep sign. And if we have different signs, we subtract and take sign of ever there is more of. Okay, so again, if you need to go back and review, go watch that previous video again. But there's just the quick reminder for those adding rules. So now for the second one, keep the first number the same, change to addition, and change the sign of the next number. So here, my next number was +3, I made it negative. My number here is +7, I make it negative. So negative and a negative, they're the same sign. I'm going to add and keep the sign. Keep the first number the same, change to addition, and then change the sign of my next number. So it's going to be +10. So here I have 16. Keep the first number the same, change to addition, and then change the sign of the next number. So -4 becomes +4. So I have a +3 here. So I have different signs, so I subtract, but I have more positive, so it stays +3. Okay, so we keep the first number, always change from subtraction to addition, and then just make sure you change the sign of the second number. So here that +3 and 7 become negative, or that -10 and -4 become positive. Now, just as a little side note, for those of you who are more comfortable with this, I'm just going to rewrite the problems really quick. Some students like to also make these changes right on the problem instead of rewriting, and that's okay if you're comfortable with it. So if you like this, then you can skip over this part. But if you're pretty comfortable with sign numbers, you're like, I've been doing this for a while, I kind of know how to do it, then you can also do it like this. So you can keep the 5 the same, change it to addition, and then change the 3 to a negative. And then again, you still get 2. Keep the first the same, change it to addition, and make the 7 a negative. So instead of rewriting the whole problem, I'm just changing the problem instead, right on top of it. Here, keep the first number the same, change to addition, and make this -10 a positive. So 6 plus +10 is 16. And again, finally, keep the first the same, change to addition, and then change that negative to a positive. -1 plus 4 is +3. So this way is just a little messier. Notice that I'm doing the same exact thing. I'm just, instead of rewriting, I'm doing it on top of the problem. So if you can keep this straight, then that's fine to do it that way as well. I know that's kind of how I learned it, was to do it right on top of the problem. But if you find that you're making a lot of mistakes, and I do see students make a lot of silly mistakes trying to do it this way, I really suggest you just rewrite it. It'll be nice and clear for you to work with. Okay. So let's just do 1 or 2 examples of using our keywords again. So obviously subtract means we're subtracting, but remember that keyword of from is going to switch the order. So subtract 4 from -2 means I have -2 minus 4. And then what we can do is we can use our rules. So I keep the -2, I change this to addition, and I make that +4 a -4. Now I can see that -2 plus -4, I have the same sign, so I'm just going to add these and I get -6. If I write something instead like subtract 4 and -2, I don't have that keyword of from. So remember, from and than, like less than, those are your 2 keywords that switch the order. So here I don't have that, so I'm just doing 4 minus -2. So I start with the 4, I change to addition, change the -2 to +2, and my answer is +6. So you can see that it's really important to watch the lingo here. So let's do -8 less 3. So I see the word less here, which means subtraction. I don't see the word than, so it's -8 less 3. So I keep the -8, change to a plus sign, and the +3 becomes a -3. So -11. If I say -8 less than 3, again, that than is another word that switches the order. So I'm going to go 3 minus -8. 3 stays. We change to addition, and then my negative becomes a positive. So you can see that, again, the order really matters because it's changing our final answer, the sign. So just watch out for those keywords here. All right, I'm just going to do a few more examples just to keep practicing. So let's do an example that has subtraction and addition in it now. So how about 7 minus 4 minus -1 plus 6? Now, go back to your order of operations. When you have subtraction, it is not commutative. It is not associative. You have to go in order. So you do need to work left to right here. That is really important because subtraction is not commutative. Or associative. So we can't rearrange things once we see subtraction. So I'm just going to go one piece at a time. So I'm going to start here. Now, I can change this over, but 7 minus 4, I can do that, right? 7 minus 4 is just 3. So if it's just a regular subtraction, you don't really have to rewrite everything. So notice I'm just rewriting the rest of the problem now and staying in order. So next I'm going to do this part here. So I have 3 plus, and then -1 becomes +1. So this is going to give me 4. And then I bring down the +6. And 4 plus 6 is obviously 10. Now, if you're comfortable kind of doing your work all together and you don't find it too messy, what a lot of students will do is they'll go through and they'll change everything over right in the problem. So they would change the subtraction to addition and make the +4 a negative. They would change this subtraction to addition and make the -1 positive. So that's another way to do this if you don't want to rewrite everything. And again, you're not making mistakes. That's important, is that you can do this without making mistakes from being, too sloppy. Then you can do it right on the problem. So now here you're still getting 3, and I'm getting 3 plus 1 plus 6. Here you're getting 4, and then you're still getting the same answer, but it's just saving you a little bit of writing along the way. All right, I see a mixture of addition and subtraction, so I'm just going to go in order here from left to right. So I'm going to start here first. It's already addition, so I don't have to change anything over. And I have different signs, so I'm going to subtract. I get 8. I have more negatives here than positives. I have -12 versus +4, so this becomes -8. Now, when you're adding with 0, or even when you're, when you're adding with 0, whether you're adding with a positive or a negative, it doesn't matter. Adding with 0 is not going to change anything. So this is going to just say -8. And then finally, I do want to change this subtraction over to addition. -2 becomes +2. And my final answer here will be -6. I have different signs, so I subtract. I have more negative, so it's -6 instead. And again, just as a side note here, what some students like to do is they may want to change over that subtraction right away. So they may go through and say, okay, anytime I see a subtraction, I'm going to make it addition, and I'm going to change the next sign. That's okay to do as well. You're still going to go through and get the same answer step by step. You just want to be careful that, again, you're doing it correctly and you're not making any little, not typos, but little tiny errors by being too messy. So if you're making mistakes, just rewrite each step. But if you want to go through and change that subtraction right in the problem by doing the same keep, change idea, then that's fine as well. You're going to get the same answer there. Right, let's say we want to evaluate, see, x minus 2y, or x equals -8, and y equals 1. Oops, since the letters are evaluate. So I'm going to let my x value here be -8. I'm going to let my y value here be +1. So I'm going to use parentheses when I plug in. Just makes things easier. It helps to remind you. Here, for instance, 2y means 2 times y. I multiply that by my 1 value. You do want to use the order of operations, though. So if you have multiplication, it does have to be done first. This becomes -8 minus 2 times 1 is 2. I don't really need the parentheses here. You can if you want to help show the negative, but they're not necessary, so I'm just going to drop them. And now I have to deal with the subtraction. So the -8 stays, minus becomes a plus, and that 2 becomes a -2. And again, if you want to do that right in the problem, you can. I like to use a different color, at least if I'm going to do it right on the problem, just so I can see my work. And then finally get our final answer here of -10. All right, I want to do one last example here and just do an application problem. So we have the following. The highest point in the US is top of Denali at a height of 20,320 feet above sea level. The lowest point in the US is Death Valley, California, which is 282 feet below sea level. How much higher is Denali than Death Valley? And just as a side note, this is from the US Geological Survey. All right, so if we read through again here, we see we have a few pieces of information, right? So I see that the highest point in the US is Denali, which is 20,320 feet above sea level. So that value is a positive value because it's above sea level. And then the lowest point is Death Valley, which is 282 feet below sea level. So that would be the value of -202 for feet, right? Because it's below sea level. And our question is, how much higher is Denali than Death Valley? So how much higher? This is a comparison question, right? Or a change question. So this question is a subtraction problem. And students always get these wrong because they miss the negative on the 282, or they miss that it's a subtraction problem. So what we're doing here is we're looking for the change between the two. So we're looking at, well, how big of a difference is it from 20,320 feet above sea level to 282 feet below sea level? So what's going to happen here is you're going to change to addition and change this to a positive. So you actually end up adding in this case to get the answer. And you could do this out. I'm going to save us a little bit of time here, and you're going to get 20,602 feet if you go ahead and add those together. Now, in case you're wondering why this makes sense, let's draw a picture. Now, obviously, my picture is not going to be perfect, but let's say I have a mountain here. Okay, so I have a mountain, and then I have some land. So here's Denali, and I'm at 20,320 feet. Okay, and this is sea level. Okay. And then I go over to California, and I know they're not next to each other, but bear with me for the picture. And we have a valley, and this is Death Valley. And it is 282 feet below sea level. So notice what's happening is you have a distance of 20,320 feet there, and then you have another distance of 282 feet below sea level, or like underground. So even though you have a negative idea here, when we look at the distance is positive. You're taking that 20,000 on top and that 282 on bottom, and you're adding them together. And that would give you the total distance here. So that's why visually becomes an addition problem. So it is a subtraction problem because we're looking at change, but because the second one is negative, you end up adding the two absolute values really here to find the total distance. So again, you have that idea that distance is going to end up being a positive in this case.